All right, let's jump right in. Have you ever stopped to think that there's kind of this secret world all around us? Seriously, it's made of shapes and corners, and it's hiding in plain sight. I'm talking about everything from the way a door opens to how a cricketer hits that perfect shot. It's all about the secret language of geometry. So today, you and we're going to be detectives. We're going to uncover this hidden world of shapes and angles. So, right off the bat, let me ask you something. Have you ever really seen an angle? I know, it sounds like a weird question, right? But just stick with me here because I promise by the time we're done, you are going to see them absolutely everywhere. And here's the big secret. They're hiding right out in the open. Every time a cricketer swings their bat or a door opens up or even just watching the hands of a clock tick by, yep, you're watching angles in action. They're like these invisible corners that shape everything around us. Okay, so any good detective knows you have to start by checking out the scene, right? For us, that means we've got to understand the world where these angles actually live. Our first clues? Well, they're the basic shapes themselves. So, the first thing we do is sort our evidence. And in our case, shapes basically fall into two main groups. You've got your open shapes, where there's a gap, the lines don't quite meet up. And then you have closed shapes, where everything connects perfectly. No way in, no way out. It's really that simple. And you see these closed shapes literally all the time. Just think about it. The plate you eat your chapati on, that's a circle. The notebook you're writing in, a rectangle. Even the tiles on the kitchen floor are usually perfect squares. See? They're all around us. Okay, now inside this group of closed shapes, there's a special gang that we're really interested in for this investigation. They're called polygons. And the rule to join the Polygon Club is super simple. A shape has to be closed, and it has to be made using only straight lines, no curves allowed. So things like triangles, squares, pentagons, yep, they're all in the polygon family. And this is where it gets really cool. Because the corners of these polygons, they are super important. They're the hiding places. In every single corner of a polygon, guess what's waiting for us? An angle, just waiting to be discovered. All right, detective, we found their hiding spots. We know where they live. Now it's time for the big breakthrough in our case. What actually is an angle? Let's go back to that door we talked about. Picture it. When the door is closed, it's just flat against the wall, right? But as you start to open it, even just a tiny bit, it creates a corner between the edge of the door and the wall. That space, that opening, that corner, that's the angle. So let's get down to the nitty-gritty. An angle is actually made of just two simple parts. First, you have two straight lines. We call those the arms. And second, the exact spot where those two arms meet up, we call that the vertex. That's literally it. Two arms and a vertex. Boom, you've got an angle. Now, every detective needs a special tool to solve a case, right? A magnifying glass, a fingerprint kit. Well, for us, our most important tool is a very specific type of angle that's going to help us measure all the others. And that tool is the right angle. So a right angle measures exactly 90 degrees. And the easiest way to spot one is to look for a perfect L shape. Just look at the corner of a notebook, or maybe even the screen you're watching this on right now. That perfect corner, that's a right angle. It's our gold standard. Okay, so we've got our special tool, the right angle. Now we can start really building our case. It's time to identify all the other suspects in our investigation. Let's meet the rest of the angle family. So check this out. It's actually pretty simple. We can classify almost any angle just by comparing it to our 90-degree right angle. If an angle is smaller than a right angle, a tight, sharp little corner, we call it an acute angle. Think acute little angle. If it's exactly like the corner of a square, well, that's our right angle. And if it's bigger or wider than a right angle, forming a big, open corner, we call that an obtuse angle. A clock is a perfect way to see this in action. Look at the hands at 2 o'clock. See how they're close together? They're making a small, sharp corner. That's a classic acute angle. But fast forward to 5 o'clock, now the hands are spread way apart, making a big, wide corner. And that, my friends, is an obtuse angle. But wait, what happens if the arms keep opening wider and wider until they form a perfect, flat, straight line? Well, that gives us our final suspect for today, the straight angle. And it measures a whopping 180 degrees, which is exactly two right angles stuck together. All right, team, we've got our tools, we've identified our suspects. Now it's time for the best part. We're going to take this investigation out into the real world and start cracking the case. So when we look back at our polygons, we find a really simple but super powerful rule. Ready for it? The number of sides always matches the number of angles. A triangle has 3 sides, so it has 3 angles. A quadrilateral has 4 sides, and, you guessed it, 4 angles. A pentagon, 5 sides, 5 angles. You see the pattern here, right? It's that easy. Let's think about a kite, like one you'd fly during Makar Sankranti. That classic diamond shape, that's a quadrilateral. And if you look closely at its 4 corners, you'll find it has exactly 4 angles. Or what about a traffic sign? You know those warning signs? They're usually triangles. And since they have 3 sides, they also have, 3 angles. And what about our most important tool, the right angle? Just look at the grill on a window. It's made of a bunch of rectangles, right? Well, every single corner where those metal bars meet is a perfect L shape. That's a 90-degree right angle. They are literally everywhere once you start looking for them. So let's do a quick recap of our detective toolkit. First, we know shapes can be open or closed. Second, we know an angle is just a corner made by a vertex and 2 arms. Third, our main tool is that L shape of a right angle. And finally, with that tool, we can spot our main suspects. Acute angles, which are smaller. Right angles, which are exact. And obtuse angles, which are bigger. Okay, you are now officially an angle detective. The world all around you is your crime scene, and it's full of clues. In your room, at school, out in the park. This hidden world of shapes and angles is just waiting for you to find it. So the only question left is, how many angles can you find today?